Okay. This will probably be the easiest way to look at the test. All right. In general, the exams were pretty decent. I think the low grade was like a 14. So obviously that wasn't that decent. There was a lot of 70s, 80s, 90 plus. I think the class average was maybe like a 74, 75, kind of right where it should be. So I would say if you got at least a 70 on it, you're probably reasonably where you should be. That kind of shows that you have reasonable competence. I would, though, take a close look at where you miss points. Because some people may have earned a decent grade by acing everything but the coding stuff, which would then basically getting no points on the coding stuff, which would then be a problem. All right. The final exam will have even more programming stuff on it. So if you're banking on no programming or less programming and still sliding by, it's going to become more and more of a problem. Also remember my policy that if you do better on the final exam than you did on the midterm, I'll replace your midterm exam score with whatever you get on the final exam. As we go through here, most people did the Hello World program correctly. New keyword, this was kind of often missed at some level. Very few people just like lost all the points, but there's kind of two pieces to this. One is, what's the new keyword for? It's for creating memory. Find this new memory. And why is it needed for arrays? Arrays are stored in contiguous memory. So for example, if I have I need 100 bucket array for integers. That means I need a single integer is 32 bits or 4 bytes. That means I need 400 bytes of memory in a row to house the contents of that array. All right. So I was looking for things involving, definitely memory. The word memory had to be somewhere in there. And then, I was hoping for something with arrays being contiguous, but if you reasonably explained enough around that, that was, let's call it okay-ish. But those are really the two pieces out of that, is recognizing that arrays require contiguous memory. That's memory right next to each other. That's how arrays function. And then that the new keyword is our way of requesting memory from the operating system. Okay. Primitive type stored as a 16-bit unsigned integer. This something dealing with Unicode, that computers like numbers. So technically, we try to represent the Unicode character set, which is 65,536 unique characters. I didn't care if you memorize those numbers and stuff. You don't need negative numbers because the Unicode character set starts at 0 and goes up to 65,535. So each number corresponds to a single character in the Unicode character set. So something that kind of captured that concept. Let's see, write the necessary code to define an integer array capable of holding 25 integers. I'll just pop open Eclipse here. And I'm just going to create a new Java project for this, some of the stuff we're going to work on today. Here, I'll create a GitHub for it just so I can just dump something online real quick at the end. So I'll go ahead and create a new repository. We'll call this guy CSC250 10, whatever. I meant to call that 1027 something or other, but I can fix that later. All right, so now I have that folder, so I'll go ahead and create a new project. And we'll call this guy the location I'm going to store this in is going to be in my downloads folder. Finish, and then make sure you don't create the module. class. I'll call this guy driver. We'll get our working hello world program in here, public static void main. So there's our hello world. So for this particular question, all you needed to do was create the necessary code to define an integer array capable of holding 25 integers. We're making an array. It's got to be capable of holding 25 integers. You didn't actually have to put 25 integers in there. So that's this. Int array AR is equal to a new int array 25. Okay? So this is using that new keyword, recognizing that we needed to hold 25 of these guys. And this goes and creates this new memory and stores the beginning of that inside of AR, the pointer to where that array starts. Okay, next, write the necessary code to print all of the numbers between 1 and 100,000. You must use a loop. So kind of some of the things we've done in the first half of the semester was we're converting our Python knowledge over to Java knowledge. So this is showing that, you know, you should already be pretty comfortable with writing a loop that goes through a bunch of numbers, but the Java way of handling that. So what did I say, 100,000? Print I is equal to 0. Did I say 1 or 1 to 100,000? So it's equal to 1. I is less than or equal to 100,000. I plus plus system.out.println I. Okay, and you had to use a loop to accomplish this instead of something else maybe built into the language or something like that. All right, so that will do that. What does the following code do? So this is has you paying attention to what the different variables are actually doing. So this is printing out the current value of I as long as I is less than J. Notice that I starts off at 5, J starts off at 10, but each time through, J only goes up by 1, where I catches up by 3 each time. All right, so the first time through, this is going to print out a 5. Then that 5 becomes 8. The 10 becomes 11. Is 8 less than 11? Yes, it is. It'll print out an 8. The 8 becomes an 11. The 11 becomes a 12. Is 11 less than 12? Yes, it'll print out an 11. The 11 becomes a 14. The 12 becomes a 13. Is 13, or what is it, 14 less than 13? No, we fall out of it. So it prints out a 5, an 8, and an 11. You could have also just explained that it prints out the value of I as long as I is still less than J, with I increasing by 3 each time and J increasing by 1 each time. All right, so this is where things started getting a little sketch, and this is what we're going to focus on today. From 200 last semester, we should already be pretty comfortable with objects, the idea of writing objects. Remember, the reason that we have objects, the job of a programming language is to give us a tool that allows us to solve problems in a very similar way to how we already solve problems as a human being, right? And when we first started learning Python last semester, we were looking at Python through the lens of simple programming practice, not necessarily object-oriented programming, even though Python supports object-oriented programming. But the second half of last semester, we were looking at objects, okay, where we were, we created dice objects and things like that, where all of a sudden we start thinking about, well, in real life, when we work with things, we think about them in terms of an object. If I pick up this, everybody can look at this and say, oh, that is a phone, because it looks like a phone. Even though inside of here, where you can say that's a computer, it looks like a computer. Even though inside of here, we recognize that there's a bunch of functions that this object knows how to do, right? So, but we kind of have this concept of what are the capabilities of this when we go to think about how could I use this in my daily life. Same thing's true with a hammer. I can look at a hammer and say, ah, that object is a hammer. What things could I use that object for? What are its capabilities? What wouldn't I use an object for? Use a hammer for? If you want to make some toast, probably wouldn't use a hammer. Okay, so we think about our world, we walk through our world and problem solve in our world, and with the objects that are around us and using those as tools to solve problems. Now, our modern day programming languages have facilities for building objects. So this question was asking us to write a simple object named player. And this player should keep track of a couple of pieces of information: a first name, a last name, and a jersey number. You should include an appropriate constructor for this player. Okay, this is as easy as objects get. So let's go and I'll create a new class called player. And players are going to keep track of 3 different attributes, I believe, right? First name, last name, and jersey number. So a string, and probably an integer for jersey number. So we'll have private string F name, private string L name, private int jersey number. Then we want to have a constructor for this guy, and constructors in Java share the same name as the class. And this guy will take in a string F name, a string L name, and a int jersey number. And we'll say this dot F name is equal to F name, this dot L name is equal to L name, this dot jersey number is equal to jersey number. This creates a simple object that knows how to hold 3 pieces of information. These are the attributes or the fields associated with this object: first name, last name, and jersey number. And here's an appropriate constructor that allows us to build objects of type player. If we want to see this in practice, I can come over here to driver, and I can say player P1 is equal to a new player, Mike Littman, and jersey number 32. I can then also create another instance of player, Dave Smith, jersey number 14. So for example, so what I have over here, player, this guy is a blueprint. It is plans for how to make a player. Just like if you're going to have you've been in one of those neighborhoods where all the houses look the same. Somebody has a blueprint for that kind of house. And then you need to go and hire a constructor to build the house for you at one of those memory addresses, right? One of the addresses in the neighborhood. So here's my blueprint. This guy teaches me how I can build a player. Players hold on to these 3 pieces of information. The person who builds that player for me, if I give them those 3 pieces of information, he can go ahead and initialize my fields with those pieces of information. But this is an untapped resource. This is a blueprint that only gets used when I actually call upon that constructor, which is happening over here. I'm creating a variable, P1, of type player, and this guy is equal to, there's our new keyword again. So I'm going to get a place in memory, a new place in memory. What am I going to do with that place in memory? I'm going to build a player. So here is me calling that constructor, passing them my 3 pieces of information: a first name, a last name, and a jersey number. This player will get constructed and placed at whatever memory address new returned. And that memory address will get stored inside of P1. Similarly, I'm creating a new variable, P2, also of type player. This is going to be new memory. I call upon the constructor. I give him information for the first name, the last name, and the jersey number. The constructor goes ahead and builds me an instance of player and stores it at the memory address that new returned, and it goes ahead and stores that memory address inside of P2. So P1 and P2, these guys are both called pointers. So if I were to print out system.out.println P1, system.out.println P2, I'm going to get two memory addresses, memory address thingies, because this is the value returned by that new keyword. Now, at each of these memory addresses is an actual player. But right now, my players don't know how to do anything, right? If I go back to my blueprint, I've made everything private in here, and I've initialized stuff, but I actually don't have a way for a player to do anything that I can access. Okay, so if I want to go ahead and have a quick public void display, or let's just call it get first name. So I'll have a getter for my first name, and I'll go ahead and return this .f name from that. And this guy's going to return a string. Now, inside here, I can choose to print out P1, which is going to be the memory address where that guy lives. But then I can say P2.get first name. I could say resolve this variable P2, which is going to take me to a place in memory, an actual place in memory where that player lives. And then I'll ask that player object to get me their first name. And there's the Dave. That makes sense? Everybody follow what I just did? This was missed way too much on the exam. Hence the lab on Friday that I was live on Slack because I was sitting in a doctor's office, but I could answer questions, just you lay in an MRI for forever. But in any case, at week 8 in the second semester computer programming class, objects should not be intimidating for us. Hopefully all of you, when you see this looks pretty simple to you. This isn't like a gigantic deal when you see me write it, right? And this looks like a pretty simple type thing, and all you actually had to write was up to this point. Okay, these are objects. We should be able to invent our own variable types left and right. We've been doing this for a while. You did it in Python. Now we've done it here in Java. Okay, this should have been fairly automatic. If your syntax was a little sketchy, that's okay at this point because you maybe haven't practiced it as much as you could otherwise have. But punchline being, you should have been able to do it. All right, I would say close to half the class got like almost no points in this question. That's not good. So if you're in that boat, hopefully you just had a brain fart and like, oh, that's all you were asking me to do? Because sometimes that's what it is, right? You're on an exam, and I mean, because that was kind of the situation in what the question with, write me the line of code to define an array capable of holding 25. I got some dissertations on that one. Like 60 lines of code with random number generators and stuff like that. I also got the random stuff that you just memorize so that when you don't know the answer, you just do this dump of stuff, right? Because you don't know what I mean, it kind of felt like it was like a presidential debate where it doesn't matter what question you asked, you got the answer they had prepared, whatever that was. So, I'd ask about this and I'd get some function that searches for prime numbers or something like that, something random, just that they memorize for their notes as a go-to. Go ahead. Yeah. And then and you should be able to see the comments and stuff I made, right? Sometimes I make funny comments. Sometimes I make mean comments. All right, so not my fault. It's a Blackboard thing. I did my part. Because that's happened before. Because there's like a bunch of check boxes you have to hit in Blackboard to like make sure that all the feedback gets back. They can see the right and wrong answers and all this stuff. But I think I understand. Well, basically, I just hit all the check boxes now. Okay, good. Yeah, so I mean, you know, kind of self-assess yourself. Decide why is it you missed that. I mean, if you look at this and you're like, oh, this is magical, I've never seen something like that before, you're either not doing your homework or you're relying on other people to do way more of your homework than you should. Okay, this should not be new material to you right now. Maybe it feels a little newish with the Java aspect of it, but you should know what objects are right now. You know, maybe you're not the most skillful in leveraging objects to solve all the world's problems yet. That's okay. That's the beginning programmer aspect, but you should know this stuff. Go ahead.
On a note of that, I tried doing the lab using the text file. Can you tell me how you get the integers to be read?
We're going to look at the lab here in a few minutes. Okay. So hopefully I'll go down that path, but ask again if I don't. All right. All right. So does everybody understand this now? All right. So try to self-assess you. I mean, because remember, I have my policy that if you suck on the midterm, you do better in the final, you can fix a bad midterm exam grade. That's great. Fine. So if you had a bad day or whatever, figure out why you had a bad day. Is it incompetence? Is it being reliant on people for doing your homework? Is it not doing your homework, right? I tried to go back and when I was putting in midterm grades, not just the exam grade, but the actual grades you have in the class, if I were giving out grades today, I would go and when somebody had a low grade, I would look at the, I would look at what I commonly found. This isn't for everybody. What I commonly found is the people that got like 30, 40, 50% on the midterm were missing many assignments. Okay, so what does that do? That translates into probably an F or a low D or something like that in the, on their midterm grade. But the reason they did crappy on the midterm exam is because they weren't doing their homework, right? Ask yourself why you're not doing your homework, especially in my classes. I grade homework incredibly easily. Some of you have turned junk in and you get a much better grade than you should, right? Because I want to encourage you to go and put in those reps. That's what's going to get you ready for game day. Okay? No excuse not to do the homework. Just do it. Okay? Work in groups, get help from people, but that's kind of the next step of this. If you are doing your homework and you're putting in that time and you're working with groups because I've mentioned this many times before in this class as well as in the 200 class, you always will get to the point where you understand the solution when you see it before you can just write the solution yourself. Okay, so ask yourself, if you're in one of these study groups where you have a stronger programmer or somebody in the group that is helping you a lot and they can ultimately help you get to the final answer, make sure that you are doing your part of, even if you see the right answer in the end, doing the reps of figuring out how they got to that point and kind of writing it yourself. So you kind of put in the muscle memory type thing from it. Because it doesn't help you learn if you're getting the correct answer because they did it. Make sense? I want you to practice. I want you to help each other. I don't care how you get the final answer. I don't care about the final answer. That's the whole point of the self-assessment. I care about the journey. Isn't there a Miley Cyrus song, The Climb?
Yeah.
Care about the climb. That's what it's about, right?
Yes.
Dope. Nailed it. I don't care that you got to the top. I want to know your experience going through it. And actually, I don't even care about knowing about it. I want you to self-reflect on it because that's where the learning took place. Okay, so when you look at your grade in the class, you look at your grade in the exam, and you ask the question, why did I get this? Try to process are you doing your homework? If no, well, start doing your homework. If you're doing your homework and you're working with groups where you're not getting as much out of it as you thought you were, do something about that. That doesn't mean don't work in the group, but it means maybe hold yourself more accountable for what you're ultimately submitting because I don't care about the right or wrong answer. I ultimately care about you learning the stuff as an individual, right? Because I'll find out in the exams. You know, when you have somebody with a 100% homework average and they get a 40 on the exam, that means something's not clicking, right? They're probably not getting as much out of the homework as they should be because they're maybe too reliant on somebody else, okay? So that's the punchline. So try to assess why you missed what you missed and what you can do differently in the last 6 weeks of class to remedy that. So you can come back on the final and do better on that exam and replace any poor grade you got on the midterm exam, right? Okay, but if you have deficiencies at the point where this object stuff feels like it's brand new to you, you got to go back and learn that stuff. All right, that's stuff you should know from now, by now, because I got some like blanks. People just didn't even answer the question, and that shouldn't have happened. Like many people, I might say 15% of the class didn't answer the question. Like it was demoralizing. Okay, let's see where we at here. The conversion things, people did well on those. I've drilled that into your soul enough, but I'm going to keep doing that. You will never have a Lippmann exam that doesn't have a conversion question on it. And you'll thank me next semester when you take the 325 class, because you'll be doing a lot of that stuff in there. By the way, everybody in here should be enrolled in that class, right? CSC 325. Some of you have been overloaded into the class. I think the class is at like 46 students or something like that now. So it's possible we'll be splitting it into 2 sections. And I'm not sure how that will work. Whether Dr. Locklear will teach both sections or I might teach one of them and he'll teach the other one. But we'll, I don't know, we'll have to see. Because we can't have one section that doesn't have enough students in it and then another section that's completely full. Yeah. Yeah, because then you run into the problem, you know, if some people like one teacher, hate another teacher, so then everybody jumps ship or everybody piles into one class. And so we'll figure it out, but one way or another, you'll have the class. The reason it's so big is because this is our first year of the new major. So everybody who's in 200 right now, as well as everybody who's in 250 is taking that class next semester. You know, because that's when you would normally take it. So that's fine. We'll figure it out. It's a cool class, but you'll thank me for the conversion stuff because you'll be working with a lot of zeros and ones and bits and bytes and all that stuff in there. I think my preference would be to have a single prof teach both sections. That way you're getting the same experience and there could be some cross, help working on homework assignments and stuff like that. But one way or another, you'll have that class or we'll move it into a big lecture hall somewhere where it's just a class of 50. Yeah, probably over in the pharmacy building is where we'd have the size for it. But I figured I'd mention that because I think we just overloaded 11 people in the other day, just randomly, just so you'll get the class. We won't make you miss the class, but we might have to do some zigging and zagging. All right, write a method, count spaces, that takes a string as a parameter and returns the number of spaces contained within the string. Okay, so easy enough as long as you read the question right, Emily?
Wow, call me out like that.
It's really funny when you see somebody answer a question completely competent and it's the wrong question.
Oh, it was so wrong.
It was a harder question. All right, let's see. So what am I doing? Count spaces. So this guy's going to be called int count spaces. And this guy's going to take in a string as a parameter. And we're going to go through and we're going to count the number of spaces that are in that. So we're going to remember something. We're going to have to keep track of the current number of spaces. So int count is equal to 0. I haven't found any spaces yet. Then we're going to go through every single character inside the string. So for int I is equal to 0, I is less than s dot length, I plus plus. We'll ask, is the current character I'm looking at, is s dot char at I, is that guy equal to a space? If he's equal to a space, count plus plus. When my loop is done, I can go ahead and return count, which is my number of spaces that exist inside of that string. Make some sense? All right, so again, should be a fairly simple exercise using some of the new Java syntax you've been introduced to, working with strings. This is the length of a string as opposed to in Python, the len and putting an s inside the parentheses, asking if a particular character is equivalent to another character, all these things. This should not have been difficult. So again, if you left this question blank, you're not where you should be. All right, keeping in mind that the programming questions I'm asking on an exam are artificially easier than the questions I'm asking on a homework assignment because you're under a time crunch on an exam. Okay, so this one should not have been difficult either. Also left blank. So if you left programming questions blank, that probably means that you don't know how to program yet, which is a problem. You should know how to program at a intermediate minus level right now, or a beginner plus level right now. Leaving things blank is not where you should be. And then this last one, you know, half of you got it, half of you chose not to memorize it, even if I told you it would be on the exam. How do you tell the difference between a class method and an instance method at the time of their definition? It's the first part of the question. Well, when you're defining them, a class method has the word static in front of it, an instance method does not. When you're looking at the definition. Next part, how do you call class methods when you use it in a program? You call a class method using the name of the class in which the method was defined. Okay, so it's a static method, and that makes it a class method. So when you call it, you will use the name of the class and in which the method was defined. A couple of you answered that something like, oh, you just simply use the method name. Now, that will sometimes work, but that's not an accurate answer, and I gave you some feedback on that. You can only just use the method name if you happen to be inside the class where the method was defined, and you're in something called a static context inside that class. So for example, if I go back here, for count spaces here, this is a class method. I'm looking at the definition of it right here. It is a class method. I can technically say system.out.println count spaces, and I can give it, I'll just bang on the keyboard a bunch of times. And I can get my answer. Notice I did not put driver dot in front of that. Now, the issue here is this should be compatible with lots of things you've heard me explain in the past, is just because this works, I would not encourage you to do this until you fully understand why it works. It's never, ever, 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 ever going to be wrong to call class methods using the name of the class in which the method was defined. That will always be right. So to say, well, if I leave that off, it works, so you can just simply do that. You can say that, but that's not the case. You have to be within a static context inside of that class. So right now I'm inside of another method that is static. So my context is static inside of this class. And because of that, I can call other static methods that are inside this class directly. All right. Now, there is some funny business going on. So let me show you a non-static context here. So we'll just say int blah. And we'll have it take in nothing, but we'll just go ahead and have it call count spaces. Actually, we'll have it be a void. All right, so this is not a static context. Not a static context, but yet notice it is working here. Make sense? It doesn't give me an error there. Eclipse at the very least thinks this should work. Now, since this is a instance method, I need an instance of the driver class to call that. I can't say driver.blah here. So I need to say something like driver D is equal to new driver using the no argument constructor that's created for me automatically. And then I can say something like, well, I'll just say D dot blah. So I'm calling this instance method using an instance of the class in which it was defined. Okay, and notice that it still runs. I can go in here and I can say system.out.println, and it did work. Okay, so that's in conflict with what I just said, that it only works if you're calling that class method from within a static context. There is some magic happening under the hood where Java is making you look like a better programmer than you are. Omitting driver dot count spaces there. Omitting the driver dot is put in for you automatically at runtime when Java goes to resolve count spaces. And it notices, it first is going to treat this as an instance. So it's going to first check to see, is it anywhere in our instance methods? So you notice here when I put this dot in front of it, it highlights it in yellow and it says the static method count spaces from the type driver should be accessed in a static way from a static context. So the Java compiler is smart enough to say, look, if you just put count spaces in there and you're in a non-static context, I'm going to check the this dot for all those things first. But you know what? I got your back. I'll go ahead and check static contexts too. And I'll make it work if I find what you're trying to do there. Just because Java bailed you out doesn't mean that it logically makes sense. Get it? So the way I teach this is that you're never wrong calling a static method using the name of the class in which the method was defined. Strongly encourage you to live by that. It'll also make you have less spelling errors. Okay? Because I promise you, since this is a instance context or a non-static context, we're seeing the evidence on the other side where it's yelling at me and saying, hey, you know what? Count spaces isn't a static thing. But notice it still worked. It yelled at me. It gave me a little warning here, say, hey, you know, count spaces is actually from a static context, but you're calling it from a non-static context. Just letting you know that, you know, you're zigging when you should be zagging, but it still worked. Java made it work, not that it should have worked. So if something, right now we are in a non-static context because we are inside a method that is not a static method. Therefore, anything we do directly in here would be presumed to be being done from a non-static position. So the assumption would be that this dot would be in front of anything that we put in there. As opposed to up here inside of main, since we're in a static context, the assumption would be that driver dot would be put in front of anything automatically. My suggestion is don't let it happen automatically. If you mean this dot, say this dot. If you mean driver dot, say driver dot. Make sense? All right, so don't rely on the tools too much because that then misleads your knowledge. Because you may come to the point where you're using an older version of the Java compiler for whatever reason, and it won't do the extra magic for you. And now you've gotten used to doing something, or sometime in the future, somebody updates a Java compiler to work the way it probably should work. I think languages should be unambiguous. They shouldn't just bail you out. Okay, so if somebody updates it to work the way it should work, all of a sudden all your code breaks because you never learned this lesson of static versus non-static contexts. Make sense? We call class methods using the name of the class in which the method was defined. We call instance methods or non-static methods using an instance of the class in which the method was defined. We define class methods using the keyword static. We define non-static or instance methods by omitting the keyword static. How do you call an instance method when you use it in a program? Using an instance of the class in which it was defined. Okay, so there's multiple questions being asked there, and I got all sorts of stuff. All right, and that's on a slide to like memorize. And I think that was also backed up one day by a thread of a quiz where you were going to have to memorize that and basically regurgitate it on a quiz. So that one was missed way too much as well. All right, so that's the exam. Questions, comments, concerns about that? If you have a question about specific grading or something like that, catch me after class or on Slack or something like that. I have a class right after this, but on Slack, and we can look at it if you think you were graded unfairly. If you think I gave you too many points, let me know that as well, and I'll take them back and give them to somebody else. I've never had takers on that one. All right. So let's look at this lab. This lab was dealing with, again, operating off this idea that too many people in the class missed this idea of objects. So based on the most missed question on the exam, and it was the most missed question. All right, we're going to create a class named Golf Club. And a golf club keeps track of two pieces of information, the name and the distance. Okay, so let's go and create this class. So I'll come in here, I'm going to create a new class. So I'm creating a new object. This guy's just like my player object, except it's called Golf Club. And instead of keeping track of a first name, a last name, and a jersey number, I'm keeping track of a name and a distance. All right, so this guy's going to be called Golf Club. And Golf Club is going to keep track of a couple of pieces of information: private string name, private int distance. We'll go ahead and have our constructor for Golf Club. And we'll set those up. So this is where that this dot stuff comes in. So if you say this dot name, make sure I spell it right. This dot distance. All right. This is also a good lesson we looked at last semester. But if I say take the this dot off here, here's another reason to always use this dot when you can. So in this case, my desire is for this variable name to be equal to this value name. That's my desire. That's what I want to have happen. The issue here is that all variables boil down to their most local definition. So the most local definition of name right here is this guy right here, which is said to shadow this more global definition of name. So then what do some people do to cheat? They say, okay, well, I'll just name these variables different. Right? Now it works. And I say that's good. That's fine. You'll find plenty of examples like that from bad programmers. Because this is along that same mental line, saying, well, this works. This is just what I do. When you have parameters coming into a function, or coming into, in this case, a constructor, those parameters should be meaningful. We don't know what you're expecting from a variable named n. Wouldn't it be better to call it name? We don't know what you're expecting from a variable called d. Wouldn't it be better to call it distance? So we have the correct name for it being name and distance. But that also happens to be the correct thing we should probably call them inside the object. So now we have that conflict. So if I write it like this, I want this guy's version of name to be equal to the most local definition of name. That's where I put the this dot in front. The this dot in front. This will never be incorrect. Don't try to look fancy by omitting using a couple of short little words that will change the world for you. Okay? Just because you can get away with it sometimes doesn't mean you should. All right, so there's our constructor for Golf Club. Now, we're going to go ahead and give ourselves a couple of getters for these because we're currently private. Now, we really only need to get the name and the distance. I'll go ahead and also give myself a display method just for giggles. So we'll have a void display, and this guy will print F our thing. Name %s, distance %s, and then this dot name, this dot distance, except distance is an int. Let me just test that real quick. So we'll create a golf club, and we'll make this guy a new golf club. Its name will be putter, distance will be 20, and then we'll say gc.display. And there's our putter with distance 20. So if we go back to this in golf club, I think I've shown you this before, but this is like our F strings in Python. Remember in Python, we had that thing where you could put a little F there before our string, and then we had placeholders in here instead of the %s's, where we would say this dot name in there like that. Python supported that. In this case, I'm basically just saving myself concatenating a bunch of stuff together here. What's the question? Here, I'll write the same line, the equivalent line in Python, just so you can see them right next to each other. Okay. Let me write it this, and then we'll explain it. So just so you can see the two things right next to each other. Okay, I can write that way too. Python, it will be self dot, not this dot. Okay, so that's Python's version of that. And then I'll do another Java one here. This will be name colons, space concatenated with this dot name concatenated with space distance colon concatenated with this dot distance. So these two lines will have the identical output. This is just a more convenient way. So to answer your question, %s is a placeholder for a string. Which string? This dot name. %d is the placeholder for a decimal value. What decimal value? This dot distance. So this guy right here is equivalent to these curly brace things here that Python used. A placeholder goes here, except what Python did is it sucks the thing that you're a placeholder for all into that syntax right there, which I probably prefer. I think that's probably a better syntax. Whereas Java bases theirs off. Printf is actually an old C print library. So this is that syntax that's been around since the late 60s. So %s, this guy right here, that's the first placeholder we run into. So it'll use the first value following this comma. So this will be what our first placeholder. This will be our second placeholder. If there was more, it would look for more placeholders. So my placeholders are always, they start with a % and then a letter. So if it was a floating point value, it's %f. All right. So if I run this again, we should get the line twice. There's my putter distance, although notice here that this is print len. So there, same line twice, accomplished two different, but probably under the hood, same ways. We're out at 50, right? Okay, good. Okay, we're good. All right, that makes some sense? All right, so now our thing knows how to display itself. You know, this,
Why would we do it instead of cat?
because this is, I don't know, I think this was easier without having to end a string and then put a plus sign and then attach something else and then put another plus sign and attach something else. I mean, you're just gluing a bunch of stuff together. If you can do it in a single line like this, I think it seems more convenient to write that. If you don't agree, then do it the other way. One's not programmatically better than the other. This is more human convenience than anything else. All right, so then let's see what else we were asked to do. Sorry, so we created a class to hold these things, got that. Should be able to display itself in a reasonable way, got that. Create a class named golf bag, and this guy should hold a collection of golf clubs. So I'm creating another object. So I'll go in here and I'm going to create an object, new class. We'll call this guy golf bag. Now a golf bag is going to hold a collection of golf clubs. So I'm going to go ahead and create a private, we'll call this collection of golf clubs, and it's going to be of type array list of golf club. And we're going to import java.util for array list. All right, then we'll write our constructor for golf bag. Notice constructors are the same thing as our, have the same name as the class name, case sensitive and all. Do not have a return type. So it's public, so I can use it outside of this, but it does not actually have a return value because the return value will always be a memory address because you always call the constructor in conjunction with the new keyword. See, all those things are connected to each other. All right, so in here, I'm going to initialize my golf bag, and what that's going to require me to do is to set my collection of golf clubs to be a new array list of golf clubs. So that'll just give it value. I didn't actually give it a value up here. I actually could have, but if we want to have a use for our constructor, constructors initialize an object. And what does it mean to initialize an actual golf bag? It's to give me something that can actually hold some golf clubs. And that's going to require a place in memory to hold it. All right, so there's that. Now I want to be able to add golf clubs to my golf bag. So I'm going to create another public void add club. This guy's going to take a golf club as a parameter, and I'll say this dot collection dot add my golf club. That'll put it into the bag. Make sense? All right. Let's see. All right, so we're going to create a bunch of instances here. So I'm going to do this in a, just for the sake of time, in a fairly quick way using parallel arrays. I'll go back to my driver. Here's main. I'll go ahead and get my golf bag. The bag is equal to new golf bag. All right, so I have my collection. Actually, let's call it my golf bag. All right, and then I want to create a bunch of clubs to put into that golf bag. Now, I can just have a whole bunch of single line things, but I'm going to make this a little bit more convenient for me. So I'm going to create a string array called the club names, and this is going to be equal to putter, and here, I'm going to just steal this. So that's putter, sand wedge, gap wedge, pitching wedge, 9-iron, 8, 7, 6, 5, 4, 3, 3 wood driver.
Yeah.
Okay. So this is sand wedge, gap wedge, pitching wedge, 9-iron, and I'll steal that part of it. 8-iron, 7. Oh, I don't go down to 2 irons. This is 3 wood, right?
Yeah.
Okay, so that's going to be my collection of strings, and then I'm going to have an int array called the club distances that will be the exact same length as my collection of strings there. So that's going to be 20, what did I say, 75? 70, then
90, 100, 115, 130, 140, 150, yeah, 70, 200.
okay. So now what I want to do is I want to fill up my golf bag with golf clubs, given these names and these distances. Notice that there's the identical number of elements in each of these. So if I were to system.out.println the club names .length, and the club distances, both of those guys have 13 elements. All right, so I can go through either of those two, and bucket 0 of one of them is related to bucket 0 of the other one. Bucket 4 of one of them is related to bucket 4 of the other one, so on and so forth. So I want to go through every element of my club names, for example. So for int I 0, I is less than the club names .length, I++. Each time through, I want to add a golf club to my golf bag. So I'll say my golf bag.add. I'm adding a new golf club, so a new golf club, passing it a club name, because golf clubs require a name and a distance to build them. So I'll say the club names at bucket I and the club distances at bucket I. So my new golf club I'm building is going to be built with the name that lives at bucket I and the distance that lives at bucket I for my 2 different collections. I will build a new golf club out of that. What will I do with that golf club? I'll add that club to my golf bag. What does that golf bag do? Add club adds it to my collection of clubs. Then if I wanted to go ahead and say public void, and I wanted to write a display method for my golf bag, I can say for golf club in this dot collection of golf clubs, gc.display. So this says for each GC in this collection. So each time through, GC will be the next golf club in that collection. This is the same thing as this for loop. So for int I equals 0, I is less than this dot collection dot size, I++, golf club GC is equal to this dot collection dot get at index I, and then GC dot display. These 2 for loops do identical things. This is the for each loop version of it. This is the iteration version of it where I use I to give me access to something in the list. So you can pick your poison, whichever of those you like better. I'll just use the second one here. So this goes through my entire golf bag, asking each golf club to display itself. All right, so this loop will fill up my golf bag with clubs, and then I can ask my golf bag to display itself. I need to go into my golf club and make sure I do a \n here at the end of my display. That way it kicks it down a line, does the same thing println does. Otherwise it puts them all on a single line like it did right here. So there's all my golf clubs in the bag. Okay. Let's see, what else are we supposed to do? Now create a program that prompts the user for a distance, and your program should find the club that is closest to the distance without going over and display it to the screen. Okay, so I want to find a club that is the distance closest to a distance without being greater than it, given a distance. I'm going to write this ability into my golf bag first. So I'll go into golf bag. And I'll say public golf club get club given distance. This guy will take in a distance. All right. Now we want to go through and we want to find the club that has the smallest difference between this distance and the distance of that club in the bag without going over. All right. So for starters, we're going to have to say that we want my difference to be something gigantic. So I don't know. So I don't, let me just kind of write the thing here. So let's call this guy difference. If I say difference is -1 as a starting point, that kind of means that, oh, I haven't actually found a distance yet. Just kind of follow me here. So I'm going to go through every golf club in my bag. So for GC, golf club GC in this collection of golf clubs, I want to ask a question. If the current golf club I'm looking at, when I compare its distance to this distance that was passed in, is it less than it? I only want to do anything if it's less than that distance, right? So I want to say if GC dot, now notice here that my golf club does not know how to give me its distance right now, because I didn't create a getter for that and it's a private field. So I'll go back to my golf club. I'll go ahead and right click in here. Actually, you know what? I'm just going to write it. So I'll say public int get distance, return this dot distance. So now I've given myself read-only access to the distance of a golf club. Now I can ask in here if my golf club dot get distance is less than or equal to the distance that I'm looking for. It's only possibly the right club if it's less than or equal to the distance, right? All right, so now I want to find out, is this the club that gets me closest to that distance though? And what I have to do then is I have to compare that to my difference value. Because right now, the closest thing I have is a -1. Now, in my mind, I want to treat -1 as being like, oh, I haven't set it yet. I could go the other direction and say, oh, okay, I'll just make it a really big number. Maybe 100,000. Figure that, oh, nobody has a golf club that goes 100,000. But it is possible. So rather than taking in that chance, I'll go ahead and just write in the logic and say, well, if it's currently a -1, if difference, nailed it. Wait, no, oh, that's why. If difference is currently equal to -1, that means I can just go ahead and say difference is equal to golf club. Say this guy is the Kerr winner. So I'll set difference equal to golf club get distance. And it'll actually be distance minus that. And then I'll also set Kerr winner equal to the current golf club I'm looking at. That's only if my distance difference was currently -1. If it was currently -1, then I don't have to do any comparisons. I found my current winner. Else, if it's not currently -1, I only want to replace my current winner if this new club is a better club than my current winner. And remember, I'm only in this if statement if it's possibly a better club. That is, its distance is less than or equal to the distance I want to go. Okay, so I'll ask the question, if GC.get distance, and I want to say if distance minus that is less than my current difference. If this is a better club for getting that closer to the distance I desire, then I can go ahead and say difference is equal to this new value. And I can say that Kerr winner is equal to GC. And then when all is said and done, I should have found a golf club. Well, potentially found a golf club. It's possible that I'm asking for I want to hit it to a distance of 1, and actually none of my clubs go less than that. So that'll give us a null exception, whatever. But I'll go ahead and return Kerr winner like that. I know we're out of time, so let me just quickly run this. So we'll call my golf bag dot get club given distance. I'm going to say 185 or 188. That's fine. And then I'll tell that club to display itself. So my best club is my 180 club that won't go too far. So then you would have just added a scanner asking for that 188 number. Okay. Now, for your homework, there is a website, because I wanted you to, a lot of students have asked, how do you practice stuff outside of class? There's a website called codewars.com that I started messing with, and it has some good practice projects on it. So what the assignment's going to be for Thursday is to create an account on codewars.com, and I'll put it up on Blackboard, and find a practice exercise that you can complete. There's no guarantee that you'll all get the same starter practice exercise, is my understanding. So basically, the idea is that you need to give yourselves things to practice that are just outside your comfort zone. So my encouragement to you is keep doing sample problems on there until you bump into one that you struggle with but can finish. If you just happen to get a very, very easy one for your first one, that's fine. That technically will meet the requirements for the assignment, but I'm trying to give you a tool that will help you practice. Make sense? All right. So I'll put the link up there. It'll be a Blackboard thing. So submit a screenshot of your working solution along with your self-assessment. But I think this will give you a tool for practicing drills outside of class that, because sometimes it's hard to come up with those questions. Questions, comments, concerns, bribes.
Also, if you want practice, come to the hackathon.
Oh, yes. I put it up on Slack. I put it out in an email. Hackathon is, what day is it?
November 7th.
November 7th, which is a Saturday.
Saturday, yeah.
All right, sign up for the hackathon. There's a link to sign up for it. Great experience. I encourage everybody. I basically want to require it, but I'm not gonna basically pay you to learn, is what it's gonna come down to. So you should do it because you want to get better. Punchline. All right. I will see everybody on Thursday. 1 second. Let me get this.
Question.
Go ahead.
Mine are gonna be.
I'm having trouble finding my grade.